Okay, welcome to Algebra 2, Unit 6.7. In this unit, we're going to be solving equations, just basic equations with exponents. So we have the same base here. Yeah, we have the same base as the first thing that we shoot for. So 32 can be broken down to 2 times 2 times 2 times 2 times 2, which is 2 to the 5th. As soon as we can set the same bases, we come back to this principle, that b to the x equals b to the y, then x and y are equal. So if 2 to the x minus 1 equals 2 to the 5th, then we know x minus 1 equals 5. And then you just solve it like a linear equation. Okay, write this down in your notes. Don't ever watch these notes and not write down what's on my board. And make sure to write down your questions where I lose you, so in class we can go over those. Okay, so now we have one where it's 9 to the 2x and 27 to the x plus 1. Well, we can't write 27 with a base of 9, but you can write 9 with a base of 3, 27 with a base of 3. And now, if we have 3 to the 2 times 2x and 3 to the 3 times x plus 1, we know that the 2 times 2x equals the 3 times x plus 1. And now we just work it out. This would be 4x. We distribute there, 3x plus 3. We subtract 3x from each side. That would leave an x equals 3. Okay? I'll go through these. I'll go through other samples in the Q&A if you guys have questions. And you'll get to try to practice it a lot. So now we have Camille going to deposit $300 at 4% compounded continuously. Diego at $275 at 6% compounded continuously. And so the first thing that we would want to do is we would want to find the effective rate, which again, you want to remember that that's what you plug in here. Now it does round off to this amount. I'll definitely go through that with you. Basically, you can't do this by hand. You need to plug Euler's number into a calculator and make sure you're comfortable with that. So you would plug in 300 e to the 0.04 to the x actually on a calculator. Now, my one problem with this is we're trying to find women that have the same amount of money, and you can't set them into equations and set them equal because it would be really challenging to find, okay, when is the t the same? So the easiest way to do this would be to actually put it in the graphing calculator to the x, and then look in the table for the graph when your y values, when the amount of money is at the same place, okay? And I can go through that one as well. I think that you'll be able to get those in the graphing calculator and move forward with that. So let me know if you have trouble. And that's the end of that one. Super useful formula there. You can use it on a lot of your accounts. So have a great day.